Hey everyone, welcome back. We are continuing our journey through radical expressions and simplifying expressions that have radicals in there. So far, we talked about the basics, simplifying a radical, and we've talked about adding and subtracting radicals. We talked about multiplying and dividing radicals. Today, we're going to talk about something that's related to all of that, obviously, but just basically a rule of thumb that we follow in math as kind of a norm, okay? Something called rationalizing the denominator. And here's the bottom line. Mathematics has its own rules that we use when we express something, just like English does. So the example I would give is that it's never acceptable to write a sentence in English or language where the first letter is not capitalized, right? You would lose a point. You would go the rubric. You would lose something in the rubric if your English teacher saw you write a sentence and the first letter of the first word was lowercase. Well, math has the same type of issue where it's just not acceptable. We understand what's being said, but it's not acceptable for various reasons. And that is when the denominator has a radical in it. That is not an okay thing. If the denominator, remember, denominator is the number on the bottom of a fraction. If that number is a radical in any way, that's not okay. And so our focus today is how to fix that, or how to make it so that the radical is not on the bottom. So the first example that you see, the radical 3/9, that's perfectly fine. The radical isn't in the denominator, it's in the numerator. But in the second case, that's not okay because the radical is in the denominator. So the question is, how do we fix that? How do we make it so that the radical's not there, but still keep it the same value? We don't want the values to change, okay? So first of all, before we actually get into rationalizing the denominator, let's talk about something here. In math, there are only a few things that you can do to express or to change an expression so that it doesn't change its value. Okay, so for example, if I have the number 5, how do I keep it equal to 5, but still do something with it? Like, what operation could I do with 5 that equals 5? Well, we could add 0, right? 5 plus 0 is 5. We did something, but it didn't change the results. And that's an important part of math. We don't want to change an answer. We don't want to change a value. We just want to make it look different. Well, we could also subtract 0. 5 minus 0 is 5. What else could we do so that 5 remains 5? What other operation could we do? Well, one is we could multiply by 1. And this is the one that we're going to focus on today. Multiplying by 1 doesn't change the value. And it doesn't really even change the look if we're multiplying by 1. But we might be multiplying by things that are equivalent to 1, and you'll see what I mean by that in a second. What else could we do? We could also divide by 1. 5 divided by 1 is 5 also. So we're going to take this principle of multiplying by 1 in order to rationalize the denominator. So here's the example that I have, okay? I've got 9 square root of 3. Let's see, this is a 9 over square root of 3. Well, we already talked about it. The square root of 3 in the bottom is not acceptable. So what I want to do is I want to multiply this value, this expression, by 1. By the big, there's the bell, by the big number 1. Well, you go, well, that doesn't change anything. If I multiply by 1, it's still going to look like 9 over square root of 3. How does that change anything? Well, if we write 1 as 1, it doesn't change the look of it. But 1 is the same as 2 over 2, or 7 over 7, or 75 over 75. These are all 1. So if I were to take this 9 over radical 3 and multiply it, let's say, by 7 over 7, that's going to change the look of this. That would be 63 over 7 radical 3. Now that changed the look in comparison to what we originally started with. But notice that our problem still exists. The radical is still on the bottom. So we don't want to multiply by 7 over 7 or 75 over 75, but I do want you to recognize that when we multiply by 7 over 7, all we're really doing is multiplying by 1, okay? So what is it that we multiply 9 over radical 3 by? Well, here's the trick. You see the denominator has a radical in it. If I multiply by radical 3 over radical 3, whatever the denominator's radical is, that's what we multiply on top and bottom. Again, radical 3 times radical 3, radical 3 divided by radical 3 is 1. So this is 1, which means I'm multiplying this number, 9 rad 3, by 1, which means I'm not changing the value. I'm just changing the way it looks, okay? So now let's go ahead and do that. If I multiply by rad 3 over rad 3, how do I multiply this? Well, 9 times radical 3 is 9 radical 3, right? We can't multiply those together because one's inside the radical, one's outside. Radical 3 times radical 3 on the bottom, well, I can multiply those together because they are both inside the radicals. We learned that on the last lesson. 3 times 3 is 9, so we end up with radical 9 on the bottom. And you're going, well, there's still a radical there, so how did that help? Well, it does help a lot because we know the square root of 9. The square root of 9 is just 3, not square root of 3, just 3. And then on top, we have 9 radical 3. And so we have 9 radical 3 over 3. And then because we can see that the 9 and the 3 are both outside the radical, we could reduce each of those by 3. And we end up with 9 divided by 3 is 3, so we have 3 rad 3 on top, over 3 divided by 3 is 1. And so our final answer is just going to be 3 radical 3. Okay? All right. For B, let's take a look at that one. Another practice problem. We have radical 11 over radical 6. Now, this case, we have a radical on top. The radical on top is not the problem. It's the radical on the bottom that is the problem, right? So the question is, how do we get rid of the radical on the bottom? A tendency for some students might be, well, let's multiply the top by radical 11 and the bottom by radical 6. Well, wait a minute. Remember back here, we only want to be multiplying by 1. This is not 1. Radical 11 over radical 6 isn't 1. We want to make sure that this number is equivalent to 1, okay? Now, how do we do that? Well, the top has to be the same as the bottom. Do we want it to be radical 11 over radical 11? No, because we're trying to get rid of the radical 6. The problem is the radical 6. So we're going to multiply the top by radical 6 and the bottom by radical 6. And so we can see that radical 6 divided by radical 6 is 1. So we are not changing the value, we're just changing the way it looks. So on the top, the radical 11 times the radical 6 is radical 66. And then the radical 6 times the radical 6 is radical 36. Now we can simplify these. The square root of 36 is just 6. 6 times 6 is 36. And then 66, we can factor it. Let's see, 66 factors to 6 times 11. 11 is prime. 6 factors to 2 times 3. Those are prime. Notice it's 2 times 3 times 11. Those are all prime numbers. So this is not going to simplify any further than it already is. So our answer is the square root of 66 over 6. And our problem is solved because the radical is no longer on the bottom. There is no radical there, so we know we did it right. Okay? So we end up with 3 radical 3. Make sure I'm right here. And the next one was rad 66 over 6, and that's that. All right, so here's your time to practice. So go ahead and pause the video and do these 2 problems for me, and then come back and push play to compare what you did. For number 6, we have 2 radical 7 over radical 5. The problem is that we have a radical on the bottom, so we're going to multiply by the radical 5 over radical 5. Oops, running out of room here. And then when I multiply the top with the top, the 2 is on the outside, so that stays there. Rad 7 and rad 5 multiply to rad 35. And on the bottom, rad 5 times rad 5 is rad 25. Rad 25 is just 5. And then 35 only factors to 5 times 7. Since those are both prime, there's not going to be any pairs there, so we're just going to leave it like this. Now, if we can reduce the 2 and the 5, we should, but that doesn't reduce any further, so that is our answer for number 6. For number 7, we have 3 square root of 5 over the square root of 8. Now, there's a couple ways to approach this. Because the square root of 8 can be simplified, we could do it that way first, but I like dealing with the rationalizing the denominator first. So I'm going to multiply by rad 8 over rad 8, because that's 1, and that would simplify to 3 radical 40 on top, and on the bottom, rad 8 times rad 8 is rad 64, and we know that the square root of 64 is 8, okay? And then the 40, that actually does factor 2 times 40, 2 times 20, 2 times 10, and 2 times 5. Those are all prime now. And so we end up with 3 square root of 2 times 2 times 2 times 5. And then now we can simplify by circling a pair of 2's. Remember, 1 goes out, 1 stays in. So on the outside, we have the 3 that's still there, the 2 that went out, and then the 2 times 5 that's still inside. And on the bottom, we have 8. And so we end up with 6 radical 10 over 8. Now, our problem has gone away. The radical is no longer on the bottom, but this can be simplified a little bit further because 6 and 8 can be reduced. So I can reduce the 6 and the 8 both by 2. So we end up with 6 divided by 2 is 3. So we get 3 rad 10. And then 8 divided by 2 is 4. And so that is our final answer for number 6. All right, so sorry, number 7. All right, just making sure I'm right here. We get 3 rad 10 over 4, so that's perfect. All right, here's another example, a couple examples. Oops, as you see the answers there. That doesn't work, does it? All right, there we go. So go ahead and try those, and then come back and see how you did. For number 8, this one looks a little different. This is applying some rules that you already know, hopefully, and with the radicals. So how do I simplify this? Well, going back to math 1, we would distribute here. So radical 2 times radical 2, those can be multiplied together. We end up with radical 4. And then distribute the rad 2 over here. Well, we don't multiply the radical with the 3, so that 3 is going to stay there. And the radical 2 times radical 6 is radical 12. And then we can simplify this a little bit. The square root of 4 is 2. And then 12 can factor. That factors to 2 times 2 times 3. If you need the cake method or the factor tree, go ahead and do that. Now we have a pair of 2's. So one of those goes out, the other one disappears. So we end up with 2 radical 3. The 3 is still there, and the 2 is still there. Now here's where I see students make mistakes. Even on this line up here. They think, oh, 2 plus 3 is 5, so it's 5. No, because this 2 is not a like term with this radical. This doesn't have a radical attached to it, so I can't combine these because they're not like terms. We talked about that in lesson 2 of this unit. So we can't combine these, but the 3 and the 2 here, these two can be multiplied. That becomes 6 rad 3, and this 2 is left all by himself here. So our final answer is 2 plus 6 rad 3. All right, and number 9. Number 9 says 6 radical 98 over radical 2. Now there's a couple ways of doing this. I could rationalize the denominator if I wanted to first, so I'd multiply by radical 2 over radical 2. Or I could recognize that I have a radical on top and a radical on the bottom that both reduce by 2. So we would end up with 6 square root of 98 divided by 2 is 49. And then rad 2 divided by 2 is rad 1. And then that would simplify to 6 square root of 49 if you need to. over the square root of 1 is just 1. And we know the square root of 49. The square root of 49 is 7. So this would be 6 times 7. And then we don't have to put over 1 because over 1 is the same thing. 6 times 7 is 42. And that is our final answer. All right, almost done here. Let's see, what do we got? Nothing. I guess we are done. So that wraps up the idea of simplifying or rationalizing the denominator. It's so important that you understand the idea of rationalizing a denominator. What do? We multiply by 1, the magic number 1, because that doesn't change the value. It just changes the way it looks. And when we do that, when we multiply by the magic number 1, what we want to do is multiply by 1 so that we're multiplying by the radical on the bottom. So in this case, rad 5 over rad 5. In this case, rad 8 over rad 8. And if I was to do it here, it would be rad 2 over rad 2. And then from there, do a bunch of the simplifications. Like always, if you have any questions, please comment or find me in a tutoring session. I'll be glad to help you out. Otherwise, I will talk to you all later.